There are one or two small points to add here. In the first part of the presentation, demonstrating the rotation of the core in the generator there, I mentioned that I incorrectly said that each electromagnet would draw 50 amps from the 12-volt battery. That's not correct. They draw about 8 amps. What I meant was that the two parallel circuits to three pairs to 6 electromagnets. Each of those draws 50 amps, which has to pass through H bridge switches, which are rated for about 75 amps. So that's the first thing. That's just a mistake in the fairly clumsy presentation, I'm sorry. The second thing that I omitted to mention was that with respect to the frequency of the rate at which the core will spin. At the moment, I think it's probably sufficient. I'm thinking 4 to 8 hertz would be sufficient to demonstrate any output that might arise, might be produced in the winding. But there's no reason, even in this apparatus, but in a properly built device, there's no reason that the core can't be made to spin 3 or 4 times faster than that. Bearing in mind that the flux, the magnetic flux itself, is changing, which with respect to Faraday's law might imply that to get the same voltage effect that you wouldn't that the winding wouldn't have to pass so rapidly through magnetic flux where it's stationary. If that's a little bit confusing, I suppose. But what I imagine is because the flux itself is changing, that would increase the volt for a given strength of magnets. If you were to measure the strength of the magnets involved, the strength of the fields, that for given field strengths of the magnetic field, you wouldn't have to spin the rotor as fast to get the same result by Faraday's law. But that's speculative, and presumably whatever properties this current has would be optimized at some given frequency or other, depending on the context and the application. But that's for the future. For the moment, I would just, in timing the switch, I would set it to somewhere between 4 and 8 hertz. All right, that's all. I'm sorry that it's a rather lengthy and clumsy presentation, but most of the information there is necessary. Most of the necessary information is there. All right, so thanks a lot.